This is part 2 of CloudOffice specific to AWS deployments. Let's get started. I'm at the GitHub page. I already have an AWS account and I performed the steps in the prerequisite guide. I'll scroll to the top and choose AWS and then scroll down past the prerequisites to the AWS section. We'll need to open PowerShell, I've already got it, and start Windows Subsystem Linux. Change to our home directory. We'll need to install Python 3 pip. Python 3 pip is a package manager for Python, and we'll use that to update and install the AWS CLI. Copy, right-click to paste. Hit enter. It's asking for my sudo password. That's the password we created in the previous video. I'll type mine in. And we'll give that just a moment to run. Now that pip3 is installed, we can use it to install the AWS CLI. I'll copy and paste that command, give it just a moment to run. Next, we create a non-root AWS user in the AWS Web Console with admin permissions. This is the user that Terraform will run as when it creates our resources, so we'll need to give it some pretty broad permissions. We do it through the web console, that's easy enough. I've got the web console open, I'm logged into my AWS account. We'll create the user via IAM users, then add user. So I am in the search or the services bar here, and I will look for IAM. There it is. Then users on the left, add user. And I'll call this CloudOffice. If we go back to the instructions, I'll scroll to the right. We need to check programmatic access and AWS Management Console access. Attach existing policies, administrator access. So I'll check both of these boxes. I would suggest setting a password. Don't forget it. Make sure it's complex. And then uncheck require password reset. We don't want to have to change the password once we log in. Policies. Administrator access, there it is, check it. Don't need any tags. I'll hit next. We can review it. So we've got a user, CloudOffice, programmatic access and management console access. Both of those were checked. We set a password. We did not say that the password needs to be reset. And then we attached the administrator access policy. I'll hit create. We need to copy the access key ID and secret access key. We'll use those in just a moment. So I'm going to leave that tab open and scroll down for the next command, AWS Configure. Copy this, paste it in. It's going to ask for the access key. I'll copy that. Paste with a right click, and then the secret key. Now this is normally, because this is a tutorial, I'll show it, and these resources won't exist after the video is created. But normally you would keep it secret, keep it safe. Right click, paste it in. Default region name, you don't necessarily need to set one. You certainly could do some research on which region you're deploying in and maybe set that as the default. In fact, I'll do that. So I'll set mine to US East 1. And then the default output format, we can just leave that alone. I'll hit enter. Next, we can validate that everything worked. Copy, paste this validation command, and I can see that the AWS CLI is using the CloudOffice user that I created. Next, we need to customize our deployments. First, I'll CD into the AWS specific directory. And then also navigate to that same directory in File Explorer. So copy this whole path. And you'll notice here that the name Chad is in the path. You'll need to change that to your Windows Subsystem Linux username. If you don't remember what that is, you can certainly type in who am I, and it will show it. There's Chad on mine. So I'll open File Explorer. In the address bar, I'll paste it in. And then you would change it to your username at the top here. I'll leave it as Chad because that's the name I set. The file we'll be editing is aws.tfvars. Double click it, it'll ask, I've already opened it, so that's okay, but it'll ask for a application to open in. Choose Notepad, that works fine. We're going to edit this file and set our variables. Scroll down to the variables section of the README to follow along with the variables that you'll need to set. So the first one, there's 3 passwords. There's the admin password. This is Nextcloud's web UI password for the administrator, likely the most important one. So I'll set this. I'll just set it to change me 1A. There's the DB password. This is the password that Nextcloud uses to talk to the database that runs on the cloud instance. I'll set that to change me to A. And then the only Office password, same idea. This is what Nextcloud uses to talk to only Office. You only really need to remember the first one. That's the one you'll log into as the Nextcloud admin in the web UI. The other 2, though, in case you were to ever need to recover or do some sort of logging investigation into your machine, it's handy to have these 2 passwords known and available to you. So keep that in mind. And I'll just append A. Make sure these are unique, that they're complex, and that you've saved them somewhere, right? In fact, my suggestion once we're done editing this file is to keep a copy of it somewhere safe. Next, we need our SSH key. That's the SSH key that we generated in the prerequisite video. We need the pub key specifically, and you can get that by pasting in this command. And there it is. So you can copy the whole thing. And then to copy from PowerShell, you highlight and then right click. So I've done that. And then in between the quotes, I'll paste it in. Scroll back to the left. Next, management CIDR. This is the IP range permitted access to the instance SSH and the web UI. I'll update the README here. So access to the instance, whether that's SSH through terminal or through the web UI, is controlled through this particular variable. This you can set to be your home IP address if you're deploying from home. You could set it, and what I'll do is set it to 0.0.0.0/0, and that will allow worldwide access. I would still need my SSH private key, which only I have at home, to access the instance via SSH, and I would need this password to access the web console, right? And this will allow me to access it from anywhere, whether I'm at home, on the go, on a mobile carrier, on my cell phone, on public Wi-Fi. In this case, that's what I want. If you wanted to lock this down a bit more, you could certainly set this to your home IP address with a /32, your home public IP address, I should clarify. If you don't know what that is, you could certainly type in, if you search Google and say, what is my IP? That will tell you your public IP address, right? So you would set that /32. /32 means a single IP address. /0 means all IP addresses. Next, we need the username, the one that we just set, and mine, and that's in AWS. Mine was CloudOffice. After that, the region, I'm going to deploy in US East 1. That's the region that I want to use. That's fine. Like I said, do some research on which region might work best for you wherever you're located in the world. There's probably a region close to you, and you'll want to set it to that. There's also the instance type. 1 gig of RAM is the absolute minimum that I suggest. I don't think that Nextcloud will run, especially with the Only Office add-on. I don't think it'll run with less than 1 gig. In fact, we're creating a swap file automatically later on, and we certainly use over 1 gig of RAM total when that swap file is included. The instance type micro includes 1 gig of RAM. It will work fine, and I'll leave it as that. There's the option for T3 or T3A. That's Intel, or if you have the A, it's AMD. It's slightly less expensive to use an AMD chip versus an Intel chip. After that, the vendor AMI namestring. This just tells which version of Ubuntu to deploy. Every now and then, Ubuntu, or the makers of Ubuntu, will upload a new version of the base operating system to AWS, and we can use this command, it's actually 2 commands, to determine if we need to update the base image. It usually happens about once a month or so that they'll update. So I'll paste this in. You'll notice at the very beginning of the command, I hit home to go back to the beginning of the line. I've got it set to US East 1. Change that to your region if you're not in US East 1. And then hit enter. And we can see this is the latest image. I'll copy it, the data between the quotes. And it is updated. So I was using an image from 2020, December 10th. And there is a new one from 2021, January 8th. The account number, the AMI account number, that's the Ubuntu or Canonical, the makers of Ubuntu. That's their official AWS account number. And save this file. And my suggestion is make a copy of it. Keep a copy somewhere safe. You can close it out. And I'm going to scroll back up. So we've edited the file in Notepad and saved it. We're already in, we're going to go down to deploy now. We're already in the directory, but just to make sure, I'll type that in again. We need to initialize Terraform. This tells Terraform to download AWS specific code and any other code that it needs. I'll run that. It should just take a second. Okay, that was really quick. And then finally, we run Terraform Apply. This will have Terraform read through the code that's included with the CloudOffice project, along with the customizations from your AWS variables file that you just edited, and then use your AWS credentials that you created to deploy the resources. It'll show us first the resources that are going to be created. So you can see here, there's a plan, 49 resources to be created. If we scroll up, we can see things like the VPC, the virtual private cloud, a public network, an SSM parameter. There's the only office password. It's encrypted. So you can scroll through and see all the things. I'm going to type in yes, I want it to deploy my resources. This can take some time to create. It entirely depends on how long it takes AWS to build all of the resources that Terraform tells it to. So be patient, give it a little bit. It also depends on the region, how busy the region is, right? I've seen things like this take 5 minutes, and then the next day deploying the exact same resources take 35 minutes. So I don't think it'll take that long necessarily, but give it some time and you'll get some output at the end, and I'll be back for that. Okay, Terraform has completed the deployment. It's very likely, though, that Ansible is still setting up the services. I'm going to go back to the diagram and point something out here. So let me go back to the front page of this project. And you'll see Terraform plus Ansible automation. Terraform deploys the cloud resources, things like the VPC that we saw earlier, storing the credentials with encryption, creating buckets, S3 buckets to store data. And then Ansible sets up the instance, things like installing the Docker containers, etc. So Terraform's done. We have the output here in green, and then Ansible will spawn automatically on the machine and install the rest of the services for us. We can watch that. If I go back to the README, want to watch Ansible set up the virtual machine, SSH to the cloud instance, see the Terraform output. So we've got some output here. And at the very top, we have SSH. I'll copy that. Again, that's highlight and then right click. And then right click again to paste. The first time we connect via SSH, it'll ask us if we want to continue. I'll type in yes. And we are logged into the cloud instance. And then the next command, we can check the Ansible output. With AWS, we use what's called SSM. It's a agent that runs on AWS instances. And we use this command to see the latest. Let me copy the whole thing there. Paste it in. And we can see that it's still running. It hasn't finished. If it were finished, we'd have output from Ansible at the very end telling us all the tasks that it completed, if any failed, etc. So it is still running. It looks like it's on the task to create the only Office integration for document editing, the S3 storage, and then Talk, which is like a conferencing service. You can also run HTOP, H-T-O-P. It's kind of like Task Manager in Windows, and it'll show us what is going on the instance. We can see here, it looks like the database is doing quite a bit. This third line here, Spreed, that's the actual name for the Talk application in Nextcloud. We can see the instance is super busy. The CPU is quite busy. The RAM is being utilized, just jumped up to over 800 megabytes there. So we'll give it some time, let it finish. You can, what I would suggest is occasionally run that command that starts with export, and you can watch it, give it some time, give it a few minutes. I'll be back when it's done. Okay, the output now shows the play recap from Ansible. We can see 42 things are okay, 27 things were changed, and the most important bit is probably this one here, failed equals 0. That means no problems were encountered. Everything's good to go. I'm going to log out of the instance from my SSH connection, and I'm going to run Terraform Output one more time. Terraform Output shows that output that we saw at the end after our Terraform Apply without having to reapply anything. It's probably a good idea, by the way, to also save a copy of this. Maybe create a text file, a notepad or something, back this up, just as an easy reference. So what else do we have? We have the web UI. That's where the Nextcloud service is located. I'll paste that into my browser. Your connection isn't private. You have to hit continue. That's okay. That's because we're using self-signed certificates. The connection is still encrypted. So I'll hit continue. So I'll log in. NC admin is the username. That's the default. It's not changeable. And then the password is the password we set in our variables file. Mine was changeme1a. I am logged in. Let me close this out. This is the little intro video. And let me turn off my dark reader as well. We are logged in. This is the default. You'll notice at the top here we have our files, which is where files can be stored, and I'll start there. There are some files that come preloaded as examples. And then there's also this folder, Cloud Storage. This is storage directly connected to S3. So if you remember the variables file, we set it to 30 gigs, and there are a certain number of gigs free available on the instance. If you save files anywhere other than cloud storage, you'll use up part of that 30 gigs. However, if you use this directory, your files will get stored directly in S3, and you won't have to worry about the size of the disk on your instance. What else do we have? We have Talk. Talk is an additional add-on that's included. This is similar to something like Skype or Slack, where you can create conversations between users. You can have web conference calls. You can do with camera streaming, that sort of thing, all private. And then the final one is only Office. And that's not an option at the top here, but if I go to plus and create a new document, test, you'll see that it opens the only Office application, and I can create and edit a document real time, collaboratively. If I had another user logged in, I have my document, make changes, it auto saves, everything's good to go. I want to go through the update process. The very first thing you'll see here in Terraform Output is move your vars file to be untracked by Git. All right, this is an additional step, but what it does is moves that vars file that we edited with our passwords, etc., out of the way so that we can pull in any updates to the Git project. It moves the file to a file called pvars, but it checks to make sure that that file doesn't already exist. Oops, and I need to be out of the SSH instance. So I'll run that first, and if we ls-l, you can see there's now a pvars file. That's our file, the file that we customized. Then we can run git pull. If there were any updates, you'd see them here. In this case, I've updated the README slightly, so I made a minor change. Next, if updating containers, remove the old containers. This brings the service down until Ansible is reapplied. So you would SSH to the instance. Scrolling back up to my instructions, we would remove the containers. Now, I'm not going to do this because it's just been deployed, but you would copy this, paste it in, and it would remove those containers for you. You can see the containers running, by the way, with sudo docker ps. And there they are. Let me expand this out just a little bit. And you can see all the containers. See, these have only been up for about 10 minutes or so. But if this was a couple weeks from now or a month from now, it might be wise to perform this maintenance, remove those old Docker containers, and then redeploy the service. So let's see what were the next steps. After you had removed those containers, you need to exit from the instance, right? We're SSH'd in, so I'll exit. Rerun Terraform Apply. This ensures that all the infrastructure is up to date, not just the instance. If there are no changes, we should get an output from Terraform that says no changes were made, or no changes need to be made. And if I scroll back up, apply complete, nothing was changed, right? So our infrastructure is good to go, no changes are needed. And then finally, you can rerun the SSM association. That's how Ansible is spawned on the instance. So you would copy this, paste it in, and your the Ansible playbook would rerun on your instance in the cloud. It would rebuild those Docker containers using the latest Docker images available from the upstream sources. And that's about it, everyone. I hope you enjoyed it. Again, if you have questions, comments, concerns, if you run into trouble, if you have ideas, meet up with me on Discord. There's a link to that in the description of this video. Thank you very much and take care.